Pressure. So the pressure in fluids is the force F exerted by a fluid over an area A. A static fluid can exert a force against a bottom of a container generated by its own weight. So let's study that pressure. The weight of the fluid is the mass multiplied by the gravity, correct? Weight of anything actually is its mass multiplied by the gravitational acceleration g, which is 9.81 on the surface of the Earth in general. Mass is the density of the fluid multiplied by its volume, rho equal m over v, so m is equal rho times v. So if we take these two equations, the weight is equal mg and rho equal m over v, then m is equal rho times v. Let's consider a fluid like water with a height h within a box that has an area A. The bottom has the same area, correct? The bottom where the water is pressing against has the same area. The volume of water over that bottom is equal to the height times the area. That's the volume. So what is the pressure exerted over the bottom? So pressure is equal force divided by area. The force is the weight, of course, considering that the atmospheric pressure is negligible, divided by A, is equal mg divided by A. So P equal m is equal rho times v, correct? That's the formula between the mass and the density. So P equal rho par v, rho times v times g, divided by A. Now, the volume is HA, is the height times the area. So it's equal to rho HA times G divided by A. A cancels out and you get the pressure, which is the pressure of fluids, is equal, and water in general, is equal to rho GH. That's the formula of pressure for liquids. Hydrostatic pressure. Hydrostatic pressure refers to the force exerted by a fluid at rest against the surface of an object that is submerged. It's not like a flat surface at the bottom. It is an object submerged within water or any other liquid. These forces push against the entire surface exposed to the fluid instead of only a flat bottom, and they are heavy due to pressure distribution caused by the fluid's weight. So we know that the pressure in the water or any liquids is rho GH. We know through the formula found in the previous slide that pressure increases with water depths. For a submerged surface, the force is given by F is equal to rho G AH, where A is the area of the submerged plane, the entire area where it is exposed to the fluid. It's not the flat upper surface. It is the entire area, okay, except perhaps the slight bottom where there's a contact against Earth, okay, or against the seabed. So F is the force in Newton, rho is the fluid density, G is the gravitational acceleration, 9.81, A is the entire area, external area of the body that is submerged, and H is the centroid depth, meaning that it is the center of gravity of the depths, where or like the center of gravity of the object, okay, where, you know, because the depths will vary against that object because it has some thickness. So you have the depths at the pressure at the top and the pressure at the bottom. Let's say you have a stone that is, you know, 2 tons, okay, so it has a varying height within the liquid. So you need to get its center of gravity or centroid, and the centroid depth is the depth used within this equation to define the pressure against that center, which is rho GH bar, times A, which is the entire area that is exposed to that fluid pressure. So the center of pressure is the point where the sum of all force vectors act, okay, or center of gravity. It is, you know, below the centroid. Actually, yeah, the center of pressure, HCP, is the point where you have, it is related to the centroid, but it's not actually the centroid. So you have, let's say, an object which is inclined within water, the pressure increases with depth, of course, against that object. So HCP, or the center of pressure, is equal to H, which is the center of gravity or centroid, plus Ig divided by AH bar. Ig is the moment of inertia about the horizontal axis, which, you know, the tendency to rotate because it is slanted. So it is the moment of inertia about the horizontal axis through the centroid, okay? So relative to the center of gravity. A is the area of the submerged plane, the external area, and H is the centroid depth. Centroid being the center of mass or density. Now, how to get the centroid? The centroid, or center of mass or gravity of an object, is the average value point of all mass points throughout the area, calculated on both x and y axes to find the coordinates of that centroid, the exact position, okay? So mathematically, that is the average of an integral or sum throughout the area of the object, that the average integral. This is technically what it is. Let's suppose you have a point which is mxy. Let's find x bar and y bar, which is, the central point, the central x coordinate, and the central y coordinate for that center of gravity. X bar is equal 1 divided by a, which is the entire area, integral x dA. Y bar, the same thing, 1 over a, integral y dA. So m has the coordinates x bar, y bar. If you have z, let's say we are talking about a 3D object. So z bar is equal to 1 divided by a, integral y dA, z dA. Okay? So it is the same concept. It doesn't change. Okay? So let's say you have a curve and you need to get the center of gravity for that curve. Okay? Let's say the curve is y is equal to x2. X bar is equal, okay, x2, let's say it extends from x is equal to 1 to x is equal to 2, correct? Or from 0 to 1, okay? So it is 1 divided by 1 minus 0, integral between 0 to 1 of x2 dx. In such case, we are measuring according to x. So this is the concept behind it.